All right, so I'm going to go through the notes for mole conversion factors. Sorry I can't be there, but you should be great. So I know I warned the sub and the sub plan that you're going to complain a little bit and say, oh no, we're cooked. You're not cooked. We're going to do some practice here today. I think you're going to get this, and then we'll spend all of Monday practicing the same thing, nothing new, and also with a lab. So we're going to do great. So we did this before. So we converted from grams to moles using these conversion factors. We know that 1 mole is that 6.02 times 10 to the 23rd atoms, molecules, particles, whatever. But 1 mole is also that number on the periodic table, that molar mass in grams. We had been doing conversions with things like copper. And so we would look on the periodic table, we'd find copper, 63.55, and then we would be able to convert that into grams. Now you figured out how to do the molar mass of compounds. So something like copper nitrate, you add them all up, and then that's the same thing. That's the only thing that's new for this, is that we're figuring out the molar mass of a compound instead of just an atom. A mole is also 22.4 liters. We're going to talk about that a little bit, talk about gas laws, but we can also convert from moles into volume of gases at STP, standard temperature and pressure, something that maybe you'll remember from something that sounds familiar from the beginning of the year. So here's a new thing. I did forget to put the boxes on yours, but I think you can kind of see how it goes. It says to convert 835 grams of SO3, sulfur trioxide, into moles. So we start off with the given here, that 835 grams, and we're going to put that right into the first part. I know that it's a little annoying to write the compound, but I would encourage you to do that, because eventually we're going to go from grams of one substance into grams of another substance, and so you want to label what it is. Then, because I have that first thing, grams of sulfur trioxide, I know it has to be on the bottom of the next conversion factor. We need those diagonal units. Oh, now I'm kind of looking at, trying to make it the same. It's mirrored for me. Diagonal unit's going to cancel out. So if grams of SO3 are here, I know that there's grams of SO3 that's going to be down here. So now the question is, where does that number come from? Before, when it was just sulfur, we would find the periodic table and we would look up sulfur. Now we got to figure out the grams per mole of sulfur trioxide. The good news, you know how to do that. That's what we practiced at the beginning of the class. That's what we did last class. So we look up the mass of sulfur, and then we add it to the mass of 3 oxygens, and that gets us 80.07 grams of sulfur trioxide. So sulfur is 32.07, oxygen is 16, so it would be 32.07 plus 16 plus 16 plus 616 to add them all up to get the mass of the whole thing. I'm not going to show you how to do that because that's what we practiced last time, but that's the only thing that's new, because that's how many grams there are per 1 mole. So that goes on top, and then now we just have to solve. We're going to multiply the top, divide by the bottom, and we get 10.4 moles of sulfur trioxide. That's it. That's the only thing that's new. Let me grab my periodic table. So to go again, sulfur trioxide, I look up sulfur. Sulfur is 32.07. There's 3 oxygens. Oxygen here is 16.00. So if I wanted to do 3 times 16 plus 32.07, that gets me this 80.07 grams of sulfur trioxide, and that's grams per 1 mole, and so that's going to be our conversion. So let's try the next one. How many molecules are there in 3.7 grams of H2O? I take my given, I put it right here in the first box. Again, I'm labeling it as H2O just because I want to, it'll get messy later if we don't get into this habit. I know that diagonal units have to be the same, so I need grams of H2O that's there at the bottom. Once again, that's the only thing that's new. So now we look it up. Hydrogen is 1.01. Oxygen is 16.00. So I'm going to do 2 hydrogens. So 1.0, if one hydrogen is 1.01, 2 hydrogens 2.02. Oxygen is 16. I'm going to add those together, and that gets me 18.02 grams of H2O. And that's how many grams there are in 1 mole. But then I know that that's not what I'm looking for. I'm looking for molecules. So I'm going to put molecules on the top, and then I go back and look at those conversions that were just there and think about what's the number that goes in front of molecules. That's at 6.02 times 10 to the 23rd molecules of H2O. You can do this in 2 steps. So if you would prefer to do grams per 1 mole on top, and then 1 mole is 6.02 times 10 to the 23rd molecules, that's okay too. But I just smushed it together here on the notes. I'm looking for my calculator. Biscuits. Well, so on your calculator, now you're going to type this in. You're going to do 3.7 times 6.02. And then remember there's that E button, that exponent button. That helps us so that we don't have to worry about parentheses. So 6.02 E23 divided by 18.02. And that gets us 1.24 times 10 to the 23rd molecules of H2O. And that's it. So this right here, if you can do these 2 problems, that is the majority of the quiz on next Wednesday. So we still got a week to worry about the quiz, and we're going to review all about it on Monday. But that's it. So let's give it a try. So on your paper now, if you could look, there are 2 practice problems. There's these check-ins. So now I would like you to try these 2 problems with you and your partner. So if you're watching this as a class, please pause it and try this. If you are doing this individually, pause it and then figure these out. So give it a pause and then I'll go through them. All right, so hopefully you're back. How many molecules are there in 18 moles? So I start with the 18 moles. I know that diagonal units have to be the same, so that's 1 mole of CH4 per 6.02 times 10 to the 23rd molecules of CH4. I'm going to multiply across the top, 18 times 6.02 times 10 to the 23rd. When I do that, I get 1.08 times 10 to the 25 molecules. Notice here, we didn't have to do molar mass because we weren't talking about grams. We were just talking about molecules. Then, for number 2, how many... I'm having all kinds of tech problems today. How many grams of helium are there in 5.6 times 10 to the 23rd atoms of helium? So I'm going to start with my given, 5.6 times 10 to the 23rd atoms of helium. I know that diagonal units have to be the same. And so then diagonal units here, it's going to be that 6.02 times 10 to the 23rd atoms of helium. Then for mass, I look on the periodic table. This one, since it's just helium, is just He. We didn't have to do the molar mass. We didn't have to do the new step. So then that's 4 grams of helium per 1 mole. 1 mole is 6.02 times 10 to the 23rd atoms. And then we multiply across the top, divide by the bottom, we get 3.72 grams. So that's it. So now what I'd like you to do is to try the worksheet. Do your best. Please don't give up. Ask your neighbor for help. And then if you want to do some of these problems on the board, you can. But give everyone a chance to try to figure this out. I will be back on Monday, and then we will go through some of this and then do a lab. You got this.